So, have you ever wondered that how we can perform a spike testing and how it is usually performed at industries, or what is the industry standard to perform the spike testing, and how do they actually perform and measure the efficiency of a system by doing the spike testing? So, behold your horses, because in today's video we are going to see all about the spike testing and how we can perform the spike testing using the JMeter. So let me start the video without wasting much time. So before we move into the actual practical demonstration using the JMeter, that how we can perform the spike testing using JMeter, I would like to bring you the definition or the usual term what the spike testing means. So what is it basically? Spike testing is, so the testing tests the ability of your software to perform under the sudden spike of user traffic. So as the name suggests, the definition is very clear. So the spike is often expected to happen in real life. So let's say for an example I can give you, let's say we have a Amazon sale going on tomorrow. So what will happen for the Amazon infrastructure is, so tomorrow most likely when the deal or the offers are going to start, the more number of users will try to go to the Amazon URL, the main URL of the Amazon. So in that case, at the time when the deal or the offer is going to start, the spike of user will be expected. So you should have a good infrastructure that can support or that can handle this expected spike of or the unexpected spike of user. So in real world scenarios, what they will do is they will perform load balancing, or rather not load balancing, they'll perform the horizontal scaling and vertical scaling. But that's not the topic of today's discussion. So we are going to limit our discussion to how we can perform the spike testing. So as the spike is often expected to happen in real life, this becomes very important type of testing for the sub part of as the sub part of performance testing. So this is the example. Let's say we all are users and we are going to make a request to our whatever the application that we are testing for. We might have hosted on some servers. So all the users will go to this server through the internet. So now what is the normal flow for any of the tests that we perform on the JMeter? So there will be some startup delay. Okay. So this is first of all, this is a graph over time and the active users. So active users, what I mean by active users is the threads that will be created by the JMeter. Now the normal flow includes 3 delays, which is startup delay, ramp up period or ramp up delay, and last is cleanup time or cleanup delay. So the first is startup delay that we can configure through the JMeter, which is nothing but the delay before the tests can start. The second delay is ramp up period or ramp up delay, which is nothing but the time which we want to take by the or to occupied by the JMeter before all the users can start their execution or start or they can go active. So let's say we are simulating the traffic for 100 users. So before all those 100 users can be active, we might have some ramp up period. So all the 100 users won't be active, won't get active at the time of the start of test, but if rather they will take some time. So this curve that you are seeing over here, that is ramp up time, and we can set this delay from the JMeter GUI. Now the test will be live for some amount of time, and here for just the demonstration purpose I have kept this straight line, but in reality the line won't be straight because the active users will be changing over the period of time until the test is not the endurance testing. In that case, the active users the line will be straight. We can observe the straight line. As the endurance testing tests the endurance, so we will have a loop for the users so they will be a straight line. So that we will discuss in later. But after that, the third delay is cleanup time. So the test is executed, the test is about to end. So before the test actually end, there will be some cleanup time. So the cleanup time is nothing but, let's say there are some active threads. So to make make those threads inactive and stop the execution, we need some time. That is cleanup time. That is not something we can set during while the or on the JMeter GUI. That is the default thing that will happen in the background. We won't even know about the cleanup time. That is not even our concern. Just these two things, startup delay and ramp up period, that is important for us. So now for the load testing, as we have seen the earlier videos, we have seen the how we can perform the load testing. So this is the normal flow or normal graph that you can observe for the load testing. So we will have some let's say the user that we have configured. We will have some startup delay that we have configured from the GUI. We will have some ramp up period that we have configured from the GUI. We won't have this cleanup time, but this will be there in the background. Now for the load testing, we don't have this line going up to the 500 users, because we will have a loop count 1 while we are performing the load testing. That's why, let's say there are some threads that are that have started their execution, and let's say the request they have made, it's completed. So the thread lifetime for that single thread will not be will be no more from now onwards. So during this ramp up time, there will be some threads that might finish their execution. That's why this line where the all the 500 threads will be activated. So the active users won't scale up to 500 users, because there will be some threads that have finished their execution while the ramp up period is still going on. So that's why we observe this kind of curve. Again, for this stress testing, the curve will be similar, just that we will now have this line more compared to the load testing. So in load testing, we will perform for the expected number of users, and in the stress testing we will go beyond the limits of the expected number of users. So that's why this line will be more this line will be on top of the line that we can see for the load testing. Now when it comes to the spike testing, this is the main thing that you need to observe. So while we keep some ramp up time for the load testing and stress testing, we don't have some ramp up period for the spike testing, because we want to simulate the spike of the users. So let's say we are simulating the spike of 500 users. So there will be some startup delay, or we can also neglect or we can keep the startup delay as 0, but it is good to have some startup delay. So let's say we have some startup delay when we have the ramp up period is equal to 0. The cleanup time will be there even if we don't want it. So now in the spike testing, we will have this spike of traffic. So if you have seen while we have ramp up delay, the line is the more steep, but here as we are simulating for the spike testing, so this curve will be not that much steep. There will be some time before the 500 users can actually start their execution, but this will be very negligible as we have kept the ramp up period 0. So this is how the typical spike testing the graph for time versus active users will look like. Also, one thing to note is you won't see this line touched for the 500 users, because while all the threads are becoming active, there will be some threads that might have finished their execution while this much of time is required for actually 500 threads to become live. So that's the one thing that you need to keep in mind. So these are the things that you need to take care while you perform the performance testing, because these are the things that will be happening in the background, and I think this is good to mention before we actually start the spike testing demo. Now let's look at the activity 4, where we are going to see the JMeter on spike testing. So we are going to perform the spike testing practical demo using the JMeter. This is the typical item layout that I have kept but is not necessary to have this kind of layout. So from here, from this terminal, I'll start the JMeter, which will give me this GUI. Now here I have reports. I have the just a second. I have this test plans created by me, and again I have the reports. So for the report storage, I will make, so I have this load testing folder created for the previous video, where we have seen the load testing and stress testing demonstration. So now over here only I'll create a folder called spike testing, and I'll go inside that spike testing folder, and over here all the reports will be generated. Now I'll make sure that there is no test.jtl file created from the previous test, and now I will configure this spike testing. Now the configuration of spike testing is very similar to what we have seen for the load testing and stress testing. So if you remember, we had a request going on this page. This is a GitHub. This is a site hosted for the GitHub, which is nothing but the project made by me. So as we are testing on the GitHub, so let's just perform our stress testing on this URL only. So to grab that earlier template, I can just go and click this open recent, and from open recent I can open load testing demo. So this is typical demo that we have used for the previous example. Now what I'll do is I will save this test plan under the same test plans by handle folder, but I'll name it as spike testing demo. I'll save this. Now there are just few things that I need to change. The first is I'll change this name from load test to spike test. Now HTTP request default will remain same because we are making the request on the same page. We are going for the home page only, and the assertion will be same, the previous assertion that we have kept for the earlier video. Now for the reports, I'll just need to change this path because now we are storing everything inside spike testing folder that we have just created. I'll copy this one, and for all the reports I'll paste instead of load testing, spike testing. I will hit the save button. Now in addition to that, what I'll do is I'll keep the users as 100. As we have discussed, I will make the ramp up period 0, which is required to perform the spike testing, as we don't want any ramp up delay. Now we will make the loop count 1, the test duration is 60 seconds, and startup delay is 5 seconds. So everything else is remain as it is. Now I'll hit the save again, and if you see, we are performing spike testing for 100 users on this GitHub page. Now we can start the execution. So to start the execution, we can use the command jmeter -n-t. We can give the test plan, which is test plan file, which is nothing but the spike testing demo that we have created over here. Now we can give the path followed by the -l option, where we want to store the test file. So this will be information about the test being performed. Then we can give the file or folder name where we want to store all the reports, followed by -e and -o options. Now we can start the test, and we can wait for the test while the test is being executed. So the test is executed successfully, and we don't have any errors. So now to see the content, we can open the index.html file, which will have so many good graphs and all those things that from which we can grab our observations. So this is the typical graph. So you see, this is how the graph looks for the spike testing. So you see, the number of threads will always decrease, no, from for the over the period of time. Now we can perform the test for 1000 users by just increasing the number of threads from 100 to 1000. Now we'll make the ramp up period again the 0, loop count 1, duration 60 and startup delay is equals to 5. And now we can again hit the save button, and from the CLI we can start the execution of test. But before that we will make sure that we won't have the test.gtl file from the previous test. Now we can start the command again. Okay, so the spike testing folder should be empty. So we have this folder created called user 100. So what we can do is we can just move this folder out. Okay, now this folder spike testing is empty. Now we can start the test again. So the test is started successfully. Now we can wait while the test is being executed. So the test is executed successfully, and as you can see we don't have any errors. So we can again open the index.html file just to observe the graphs, and you can see we don't have any failures for the 1000 for the spike of 1k users. And these are the graphs. As you can see, the average response time always decreases, because in the starting we have lots of threads, lots of active threads making the request, and this is how the spike testing observation is taken. Now we can again make a folder. So we have created a folder user 1000 which stores all the reports that we have generated for the spike testing of 1k users. Now again the spike testing folder is empty. We can remove the test.jtl file which is from previously executed file. Now we can again change the number of users to 2000. We can hit the save button, and we can again perform the test, and we can wait while the test is being executed. So as you can see, the test is executed successfully, and we have some errors. So we can open index.html file, and as we can see we have 3 failures from the 2000 samples, which means from 2000 users the 3 users might be facing the issue. So the issue is for all the 3 of users nothing but the connection reset, as it is expected, because the servers that are handling this request, they might not have that much of memory to keep this much of connections active at the same time. That's why we are observing this kind of errors. So as you can see, now what we can do is we can compare all those graphs. So we can go one folder up, and we can open the graph for the 1000 users. So this is the graph. This is the observations that we have taken for the 1000 users, and we can open the response time overview, and this is the graph that we have taken for the 2000 users. So as you can see, for the 1000 users we don't have any requests that are in error, but all the requests that we are seeing, that all the request has response time greater than 1.5 milliseconds. We can also see the graph of time versus active threads, and over here also for the 2000 users, as you can see the response time is 20 seconds. So the maximum response time that we are getting is 20 seconds for one page load, but over here we have just around 10 seconds or 9 seconds, as it is expected, because for the 1000 users we have the spike of 1000 users. At that time the users are increased 100%, and the average response time is also increased to 100%. So I hope you have got the idea about how we can perform the spike testing and how we can you know make our observations using these graphs that are generated by the test that we have that we perform. So that's it for this video. We will meet in the next video. Till then, keep learning and keep exploring. In the next videos, I'm planning to cover the endurance testing and distributed load testing. Let me know in the comments if you want if you have some video suggestions for me to make. And yeah, that's it for this video. We'll meet in the next video again. Keep learning and keep exploring.